The topic of this webinar will be API basics and its practical application. This webinar will be done by me and two of my colleagues. My name is Mohsen Gaemi. I'm sitting in StruSoft, Hungary, in Budapest, where we developed the FEM-Design. And in this webinar, what we are going to have, I will have two of my very smart practical structural engineer colleagues here. The first is Andreas Skarsson. He was a practical engineer. He was working as a designer in a Swedish company. And he was really a little bit bored of making the repetitive jobs, and he has a programming knowledge, and he thought that he will use his programming knowledge and will automate his repetitive job to a computer code, and that's why he joined us in StruSoft company. He's sitting in Gothenburg, and he's a API engine developer. Now it's a few years that he do this amazing engine for us. And after, or we will have the Igor Mozdeka from Nord Consult. He had also similar feeling with the repetitive jobs. So he thought that he will use his programming knowledge beside his structural engineer knowledge and make automatize his model. So today I will just introduce the StruSoft company to you, and my colleagues will help with the other stuff. But before we start, I would like to ask you to use your, if you have any question, use the question dialogue in the GoToWebinar, and please write your questions. We try our best to answer your question during the webinar, but if we are not able, we will answer all the questions by email. So let's see what's the agenda for today. As I mentioned, I will introduce a StruSoft company, and after that, Andreas will show you the FemDesign API engine what he developed. Then he will introduce a simple example with the API. Afterward, Igor will take the word and he will show his C# code with a simple example. Then finally, Igor will show us his fish tank project, where he automate many calculation and many geometrical modeling in this project, and he saved a lot of time. Actually, we can say that he usually used to have 10 hours of the job to a couple of seconds now. Let's see who is StruSoft. We have lots of other products than the FemDesign. As you can see here, one of the biggest product of StruSoft is FemDesign, and you are probably familiar with this product, where you can analyze and design the models in 3D, and there are many other capability here. The next is a WinStatic. This we can say is like a calculator for the engineers. These WinStatic is a bunch of the 2D programs, and you can take it any module and have a quick calculation of the memory that you want. The next is the beam energy, when you can calculate the energy consumption in the building. Here we have the impact precast and impact reinforcement. This is for the prefab factories and also the designers. In the impact program, you can start with the sketch of the structure from the beginning, where you start to sketch it, to model it until the element is erected in the site. It's included everything, and transportation, tracks and design, and lots of other things. So it's a full solution for the prefab factories and prefab designers. The last is the pre-stress. This is a small 2D program that's very useful and powerful. It can design the pre-stress elements. StruSoft is, as I mentioned, that we are originated from the Skanska. We start to make our programs from 1982, and you can see we have lots of milestones in the StruSoft history. The last is the FEM-Design 20, which was released a few weeks ago. We have more than 10,000 users worldwide in lots of countries, more than 20 countries. But as you can see, we are concentrated in Europe and also mainly in the Scandinavia. We are very strong there and market leader. StruSoft has lots of offices also, 3 in Sweden, where the headquarters is located, 3 in Denmark, and 1 we have in Hungary, in Budapest, where the FemDesign development is done. We have offices in Finland, Estonia, Romania, India, Manila, and the UK. FemDesign can collaborate with many other programs. We start the collaboration from the very beginning, very early version of the FemDesign with the DWG and DXF, and of course we continue with the beam integration. We can connect directly to Graphisoft, ArchiCAD, to Tekla, to Revit, Dynamo, Grasshopper. And also we have some other connection like IFC. With FemDesign, you can do a lot. You can have a foundation design for the foundation design, and you can have 3D soil and a pile, 3D soil with the 3D elements. Borehole with RC design, you can have the bar surface punching, precast, and the fire design. With the steel, also you can have bar designs. We have the steel joint, 3D shell, and the fire design. With timber structure also for the bars, for orthotropic CLT panels, and the fire design. And this year also we came up with the design of the composite columns. So it was a short introduction to StruSoft. Now I will give the word to my colleague Andreas to continue with the presentation. Yes, please, Andreas.
Let's see. So, hi everyone, and thank you, Mohsen, for the presentation. Sorry about this. I'm gonna have to do it like this. Yeah, so my name is Andreas, and my goal here today is to do a short introduction of the FemDesign API tools. And as Mohsen said, I work as a developer, but also as a customer success manager at StruSoft. And as a developer, my role is to serve our customers or you with easy-to-use API functionality for FemDesign mainly. to help you increase your productivity and kind of explore new design opportunities. And as Måns said, my background within this is that I used to work with parameterization at my previous employer. All right, so first of all, I think that it's worth mentioning what an API actually is. I think there's a lot of confusion about this sometimes. So API is just an abbreviation for application programming interface, which is in short a set of rules for how you can communicate with an application through programming. And basically FemDesign has an API which can be accessed in a lot of different ways. So who are using the FemDesign API and why are they using the FemDesign API? When I go to LinkedIn, I tend to see a lot of posts like this. They're usually filled with different kind of spaghetti graphs, magically creating some FemDesign model, followed by tags like hashtag FemDesign, hashtag API, and hashtag parametric design, and so forth. I suppose you've seen similar posts to this, and maybe you're not really sure what these engineers are trying to communicate. So in the center here, we can see a post by Igor a couple of months ago, where he tries to present one of his projects that he is doing a presentation on later on today. And I see my presentation here only kind of as a segue to his, to be honest, because his presentation is the actual interesting stuff. All right, so but what are these posts about, and what are these engineers trying to achieve? Basically, these engineers are using the FemDesign API as a tool to create complex geometry, run iterative analysis, automate model creation, automate analysis and design tasks, and much more. All of this in order to explore maybe new design opportunities, but also in order to increase productivity and quality, or maybe just because they think it's a fun way to go about their everyday tasks. So how can you guys use programming to leverage FemDesign like these engineers, and what's more importantly, what tools are available? And this is where it sometimes becomes a bit tricky because the FemDesign API can be accessed by a lot of different tools. For example, Grasshopper, Dynamo, C#, Python, but also many more. Sometimes it can be quite difficult to figure out which tool one should use. But in the end, it kind of depends on your programming experience and your preference. So, but I would generally say that if you are mostly curious about the technology, and maybe that's the reason you came here today, I would recommend you to get started with Grasshopper or Dynamo, or maybe Python, as these are kind of like the stepping stones into this world. But maybe you feel like a more advanced user as Igor, and you want to use the C# framework directly as he did. Maybe you even want to add a few features for yourself or for your company. And for those who don't really like neither of these, feel free to build your own plugins using the basic StruXML and FTScript data protocol. And And I think some of the confusions regarding the API lies within the StruXML and FTScript data protocol, which is the base data structure on top of which everything else is built on, the Grasshopper, Dynamo, Python, C#, and so forth. So if you feel most comfortable in an environment like this, or you're curious about this, maybe visual programming is for you, and Grasshopper and Dynamo is your go-to tool. If you're more comfortable writing code like this, I suppose C# or Python would be the way to go. And if you actually know what this means, then I think you might be ready to build your own third-party tools on top of the data protocol, if you find it worthwhile. For those who do not find it worthwhile, we have all of the ready available tools for Grasshopper and Dynamo and C#, for example. So in conclusion, there are several tools available for you to use if you want to access the FemDesign API, and you should pick the tool that you're most comfortable with. The bottom line is that anyone can leverage FemDesign using almost any choice of programming environment. And if you want to use Grasshopper, Dynamo, C# or Python, I can provide you with all the help you need and the support you need to do so. And also help you add the features that you might be missing. So part of this introduction here was that I wanted to show a quite simple example using Grasshopper, showing how we can create a parametric model for FemDesign through Grasshopper. So Grasshopper is a part of a widely used CAD application called Rhino 3D. If you already have Rhino and Grasshopper, you can go get the FemDesign API toolbox at Food for Rhino. When you have the toolbox and you have it installed, a new tab in Grasshopper will appear with the FemDesign features, where you can create beams and loads and supports and run analysis and design, etc. So what I've created here, just to kind of visualize parametric model, is a hyperbolic paraboloid on top of a rectangle. It is parametric in the sense that I can change the height of this to make it get different shapes. Forgot to put on the safety hatch. And I can also stretch this region and get new shapes. So this would be a typical example of when you create something parametric and maybe some sort of a more complex structure that is generally quite difficult to do in FemDesign by hand. The practical application for this might not be very valuable for most of you, but it's just an illustrative example of how this toolbox works. So when we've created the geometry we want, I can quite easily get the points and surfaces out of this geometry with a cluster I made here. And on top of those points and surfaces, I can create my point supports, my plates with some sort of material I can create a load case, and in this case I also create a mass conversion because I'm gonna do a frequency analysis later on. I can use the toolbox to change, set the mesh, etc. So I think 0.5 is probably like I'm going to use a quite large mesh here. That's probably not accurate for design, but I want this to run a bit faster because the model is quite big. So and then I can assemble everything into a model. If I choose to open this, I can automatically open it in FemDesign. And if I would choose to, for example, change the height here to something maybe negative, I can do so and reopen the model and see the changes. I can also see, for example, my average mesh size that I set to 0.9, and I could go about meshing this. So, but maybe I want to do more things. I usually, whether this is a structure like this or something more commonly designed like a balcony slab or something like that, I might want to do something else with it. I might want to run an analysis, for example. So in this case, I'm just going to illustrate how to actually illustrate running an analysis and show you how that works. So I set up my analysis in a way that's similar to how you do it in the user interface in FemDesign. And then I can run this as well. And it will start solving this model. So why would you even bother doing this in the API? Obviously, you can evaluate a lot of different options. You can create geometries that you couldn't otherwise, but most importantly, you can start automating your tasks by doing batch report printouts, doing batch result printouts, and so forth. So I'm just going to show you like one of the eigenfrequency modes here and something else. So yeah, I can basically run an analysis as I would using the user interface. So if I wanted to do a batch documentation printout or batch result printout and continue to work with that, I could use these input parameters. I'm not going to show that in detail today, but that might be for another occasion. Instead, I kind of want to move over and give room for Igor. So in conclusion, you can leverage FemDesign using programming. And the reason for doing so might be because you want to create complex geometry, run iterative analysis, automate model creation, automate analysis and design tasks, and much more. And you can use the tool of your choice to do this. In the example I showed, I created a parametric model using Grasshopper, but this might as well have been done using, for example, C#. So I will now leave this stage to Igor, but if you have any questions, feel free to use the questionnaire in GoToWebinar, or feel free to email, call me in any way whenever you feel like it, and I will try my best to help you. All right, so thank you, and let's see if I'm going to give control to Igor.
Sorry, Igor, we cannot hear you. You're muted. Please start over.
Sorry. Hi, again. My name is Igor Muzdika. I'm working at Norconsult office in Stavanger in Norway. Andreas has been talking about several ways of how to access FEM-Design API. But here I'm going to show one of that, and this is directly from using C#. What you see on the screen here is a program called Visual Studio, which it's most common use for compiling applications written in C#, but also Python, Visual Basic, and etc. I prefer using C#. So here I'm going to present, before coming to the example of fish tanks, I would like to show you several other examples that are maybe not so practical, but they're really very illustrative. To start, I will generate the same surface that Andreas generated by using data from Excel that he sent me. So here we have a number of points and 3 points for each and every triangular element, so a plane, which surface is contained of. And the codes that I wrote is taking information from Excel file and creating plates in FemDesign using that data. One can choose concrete class and thickness of material. One can also choose placement is outside inside, which is used for automatic calculation of creep and shrinkage factor. So model is a bit big, so this will take some time. And while we're waiting for generation of the model, I would just make a short introduction of the second example, where one can generate a surface that is mathematically defined directly from application without using Excel or without using Grasshopper or Dynamo or any other program. Because C# supports so-called object-oriented programming, one can define a surface, for example, paraboloid, with all the parameters like, for example, length, width, height, and etc. I'm not going to write the whole code because this is already incorporated here. And as soon as, so this is the surface generated from Excel, and okay, I'm going to generate that same surface and some other directly from application. So this is exactly the same as Andreas generated via Grasshopper. So, and you can see that all the parameters are controlled from application, thickness 35 centimeters, and automatically calculate strain and creep factor. And in second example, it's about finished. The same surface is generated, but besides so-called circular paraboloid, also generated just a second. So-called hyperbolic paraboloid and linear hyperbolic paraboloid.
So in very, of course, this takes time to develop these classes, this object for each and every surface. But once when all the necessary classes are developed, it's really easy to generate new geometry. And of course, one can change all the parameters like length, height, width, etc. And the next illustrative example I would like to show you is example with bars. So here I'm generating two arches with concrete material that is concrete class 45, 45 or concrete section, rectangular section 300 by 600. So the difference between these two arches is the shape. First arch is follows the moment diagram of simply supported beam, while the second arch follows the deflection graph of simply supported beam. And right away I'm running analysis. So very fast one can assess the difference in deflection. So one can see that. So this is the arch that follows the moment diagram. This is the arch that follows deflection function, and one can see that there is significant difference in deflection. So one can actually define these functions as one wants and generate as many arches as one wants and see right away the differences in the results. So I'll continue right away on the next example, where we're going to generate a steel beam in the shape of sine function. So here, this parameter m defines a number of waves of sine function, a number of half waves of sine function. And one can define steel material and profile. So this will be one. Here it is. So here there's one UPE profile, another I think it was HEB profile with 4 half waves. That's 2 waves of sine function. If we just will change some of these parameters to show you how easy it is actually to make changes on geometry. Let's say 1000, maybe here IP can leave 200. 80 bars generated in a matter of seconds. And I'll just wait a bit for model to open. This. So, okay, this looks a bit strange, but you can see that there's 4 waves of sine function, and the profile is changed automatically. Section HEM 1000 and material ester 355. So after these illustrative examples, I will now show you the reason why even get interested in FemDesign API and start developing all this application. So run right away. So in Norway, we relatively often have projects of fish tanks. These fish tanks are part of a bigger system, so-called recirculating aquaculture system, where the intake water that is taken from the river are kept in the system and are recirculating and filtered in various ways. So the fishes, this is used for fish farming, and the fishes are cultivated in these tanks. So there's huge tanks, usually 20 to 25 meters of width, 5 meters of height, filled with water and fishes. And in general, the shape of the tank is always the same, octagonal. The things that change from project to project is thickness of the walls, total length, total width, ratio of this side compared to total length, and of course seismic load due to different placement, due to local conditions. So we have done previously these kind of projects manually, and that meant that all this geometry that are just generated automatically from application had to be modeled manually. And what was especially difficult was modeling loads. This is calculation done in MATCAD according to Eurocode 1998/4 that calculates hydrodynamic pressures due to earthquake loads and distribution of the masses and the loads looks something like this, depending of type of liquid and thickness of the walls, stiffness of the structure. There's different ratio between so-called impulsive mass and convective mass. They'll say the water that moves together with structure and water that moves in shape of waves, independent of the structure. So final result would be one graph like this red one, and then one would have a bunch of points that would have to be manually transferred to FemDesign. And one of the problems is one gets really big model, and on top of this tank usually one has steel superstructure, so there's additional loads from the columns. Not visible on this photo. So together with seismic loads and ultimate state loads, one gets really big model. And the main issue was once when one model is done for one project, it was almost impossible to reuse that model for another project, because if, for example, this tank is a bit wider, let's say 1 meter wider, then one needs to move all these walls there, all these walls there, and the loads that are relatively complicated also needs to be moved and stretched out. So, and this bottom plates has they're modeled under angle, maybe not so visible here. So pretty much one would need to erase whole model and start to build it from scratch. Approximately took about 10 to 15 hours to make one model like this. That now is generated in a matter of seconds. And another issue was, let's say in the middle of this project, we have suddenly a change. There's maybe change in height. Let's change my parameters. 6.1, and let's increase height for half meter. One would think, why even bother with change of half meter? But here's the seismic load incorporated in whole application. And you can easily see that total load is almost 20% higher for increasing water level for only half meter. So to change this model, because of walls are increased for half meter, it's relatively easy to stretch walls for half meter. But to change all these loads, because they don't change only at the top, they change along the whole height of the wall, it's more tedious task. Plus there's 16 load cases with similar loads. So one will have to do that 16 times for all directions and for all combinations of possible situation where one tank is empty, all other three are full, for example. So, and with application, this is done in matter of seconds. 6.1 meters and whole new calculation done automatically. For example, if one wants to has another project, wants to maybe have very big tank, let's say 31 and 18 meters, and maybe different soil type, different seismic class or different acceleration. Just I need to change just few numbers and generate a calculation again. So, and generating a model from application made it also easier to divide calculations for ultimate load state and seismic load state, because one has only one file where all the information is contained. So all the parameters that are defining a fish tank are contained here, and there's additional information about reinforcement, openings, etc. But geometry is actually defined with only these parameters. So if one generates one model for seismic limit state, another for ultimate limit state, one will get two different models with different loads, but with same geometry, with same openings, with same reinforcement. So one can divide one big model in several submodels, which makes it easier to handle documentation, make control, etc. So here we generated one big model with all the loads are following. Of course, here in this case, there's a total 26 load cases and 120 load combinations. So doing this manually would be almost impossible. I'll just make changes here to show the difference between ultimate load state and seismic load state. So I'm generating now another model with original dimensions, The only change is that calculation type is ultimate load state. As I mentioned before, there's loads from superstructure. Usually steel columns are placed on top of these tanks. And we usually get those loads from steel producer or steel designer. And these loads are contained in one Excel file with coordinates for each and every load and values for different load cases. So this information from Excel is taken by by application, and concentrated point loads are generated in defined places. Model. So let's see here. There's loads for different load cases with comments of this is axis names. So it's easy to follow and check from Excel and information that we get from Steel Designer if the values are modeled correctly in FEM-Design. And you can see that load combinations are of type ultimate and serviceability type, while on the other model that was ultimate seismic limit state are of type seismic limit state, and of course the safety factors are corresponding to combination type and also to the load category of according to Eurocode 1990. And also these tanks are usually comes in a group of 4 or maybe group of 2 or even single tanks. And with application is easy to generate, for example, a group of 2 tanks from the same code. This is the same seismic calculation incorporated in application. And I'll start closing some of these files. So now there's a group of 2 tanks generated with less load cases and less load combinations. And of course, there's another Excel file that is specific for a group of 2 tanks, and also one can generate a single tank using whole application, the same application. I'm just going to check if I forgot something. So the main advantages of developing application in C# is time saving. I'm not so familiar with Dynamo or Grasshopper, but I would assume that visual programming would be maybe too complicated for this type of application. One will get soon very many nodes and connections. So this is the single tank. Done. And load combinations. And also I forgot to mention here another big advantage of these tanks is possibility of modeling reinforcement automatically. So in this type of structure, one has base reinforcement, but also it's necessary with additional reinforcement in corners. So usually in horizontal direction, inner side one has additional horizontal reinforcement in walls, additional vertical reinforcement in vertical direction, and also additional reinforcement in plates. So developing application made it possible to have more intuitive filtering of elements. It's relatively easy, for example, to extract all outer walls, or for example, or all inner walls. Then it will be using user interface in FemDesign. So the main advantage is to save time. Before it took 10 to 15 hours to make one model, now it's few seconds. And time that was used to before time that was used to model create a model was actually it was not able to reuse. I was not able to reuse that model again because minor changes meant it would be so much work to create new model. It's better to start from scratch. But the time used to develop this application results in code that can be used on several different projects for years to come. And it's also made it possible to assess impact of changes. As you could see, one can easily change one parameter and see effect of it, if it's necessary, maybe more reinforcement, or is there some bigger forces, etc. As I mentioned, more intuitive representation of elements, easier modeling of opening and reinforcement. Here the opening is in application, opening is defined as an object that is added to the wall. So it's relatively easy to select one wall and define opening at that wall from X, Y coordinate and that diameter. The same with reinforcement. One can say that additional reinforcement for this wall is defined along the whole height from start to first, let's say, 1 meter, and so on. That, and so it's possible to divide models into submodels. Then one still has single source of truth. It means all the data is coming from one file. It's easy to control the file. It's easy to have history of what was changed, and less possibility of making mistake. There's nothing manual. There's no anything manual about it. One doesn't need to calculate loads manually. Doesn't have to model them into FEM-Design. Doesn't have to model the reinforcement manual. Everything's done automatically. And the same script is used for all groups types and all calculation types. So one can generate all necessary documentation in a few clicks. And that will be all from my side. If there's any questions.
Thank you, Igor. Just one word. I was sitting back and was looking into this webinar, and I was just thinking that if someone wants to do this by hand, is hell of the time. I mean, to modify the things, and it's very useful. I mean, effective and useful that to parameterize all the things that you want to change. So then you will save a lot of time. Beside that, you're making the less error, maybe zero error, and also with few calculation, maybe you can optimize your structure and gain lots of money.
Yep.
Yeah. About the question, I think. Yes.
That's the point. For example, with this application, one could easily make several calculations. For example, changing the thickness of the walls and calculate very relatively fast necessary reinforcement. Check what is the cost of concrete per cubic meter, what is cost of reinforcement per kilogram, and plot a function that would be x-axis thickness of the wall, y-axis total cost for reinforcement and concrete, and find optimal thickness of the wall that will result in minimum cost.
Igor, we got a question that they're asking how much time did it take to do the script for the fish tank?
I contacted Andreas about this project in August 2020. He helped me with basic FemDesign API that he presented. So we had, I think, 2 or 3 phone calls, maybe for half an hour. And the first usable script I had in 2 weeks from that. After that, it was just fine tuning and adding more and more functionality. I would say maybe in total that for developing this level of application, I use 60 to 80 hours. And at that time, I was working on 2 projects that had both quadruple and double tanks. That was necessary for different type of calculations. So if I would use 15 hours per group, I would already be in plus. Plus that this quadruple a group of 4 tanks is almost impossible to model manually. It's 120 load combination, 26 load cases. It would be really difficult to do this manually. So in 2 projects that I had at the same time, I already used less time on developing application than making these 2 projects manually with better quality and having a code that I can reuse for any other project that comes.
Okay, Igor, thank you very much. We are just running out of the time. Just a special thanks to you as a guest that you accept to join our webinar, and also thank you for Andreas to showing us amazing API engine that some other engineers like Igor can use it. Many thanks for everyone. And I hope you enjoyed this contentful webinar. And we will also have we are planning to have a webinar for education of FemDesign API. We will inform you either by email or website. Also, we will publish it in the LinkedIn. Please be connected and check our posts. Have a nice day, and thank you for joining us and spending your time with us. Goodbye.
Bye.